Hello, students. We're going to solve multi-step equations today. Our method for that is using algebra properties to form simpler equivalent equations. And once they become simpler, they become easier and easier to find the value for x. So what's a multi-step equation? Let's go back. A one-step equation is like x plus 2 equals 5. A two-step equation would be something like 3x plus 6 equals 15. A multi-step equation would be something like x plus 2x plus 6 equals 15. So there's a little bit more to do. Now, all of these equations are actually equivalent. They all have the same exact answer for x. So what does it mean to solve an equation? This is the first thing I'm going to ask you on the quiz. To solve an equation is to find the value of the variable that makes the equation true. What does it mean to solve? It means to find the value of the equation that makes the equation true. So here's a word problem that can be modeled with a multi-step equation. Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The book costs $16. Their total cost is $72. How much is 1 pack of strings? So I'm going to use the variable P. P is going to stand for the price of a pack of strings. And that can be a variable. It's a variable for 2 reasons. 1, in this problem, we don't know what it is. 2, it's the cost of something that could change. It could vary over time. Maybe 10 years ago, a pack of strings cost $1.50. And maybe in 4 years, a pack of strings will cost $12. So the price of a pack of strings could vary. Maybe it wasn't labeled well in the store, so you don't know how much they cost. But after you ring it up, you have the price, and then you're wondering, I wonder how much the strings were. So we can model this with a variable equation, So Noah and Kate are shopping. Noah buys, I'm going to put Noah in a set of parentheses. He buys 2 packs of strings, so 2 times the price for each pack of string. And then Kate, they're sharing. Kate will Venmo him later. We'll also buy 2 packs of new strings and the music book. Okay, I could put MB for music book, or I could put in 16 because I know it costs $16. A lot of times when we're doing money stuff, the total price goes on one side of the equation. So there's the total cost. And now I want to figure out how much a pack of strings is. So in this problem, the parentheses don't, and this is sort of translated from the problem. Translated from given problem. Okay, and the next thing we're going to do is we're going to basically let the parentheses go. In this problem, we don't need them because they're not multiplying anything. Okay, what do we do next? Well, we combine like terms. So I see 2 packs of strings and another 2 pack of strings. That's going to be 4 packs of strings that were bought. And now we've gone from a multi-step equation to a 2-step equation. We took a more complicated equation, and we, by doing some math, by using a property of combining like terms, we have turned it into a simpler 2-step equation. So this was called combining like terms. If someone's like, wait, what did you do? You're like, well, I combined the 2p and the 2p. Combining like terms. And then what do we do? Then we use our algebra properties. So we're going to subtract 16 from both sides. That's called the subtraction property of equality. And then there's our zero pair, and we have our 4p, 72 minus 16. It's 56. Okay, that's just called subtraction. I'm going to divide both sides by 4. That's called the division property of equality. You can divide both sides, keep it fair, keep it even. Okay, that makes a 1. So we can use our identity property. We have to do 56 divided by 4. And I kind of ran out of room. I'm going to go over here today. So I have 1p is equal to 14, and p is equal to 14. Is that reasonable? $14 for a pack of guitar strings? I guess so. It's a little more than I was thinking, but I guess that's how much they cost. Yeah, it seems reasonable. So 2 times 14 is 28. 2 times 14 is 28. 28 and 28 is 56. 56 and 16 is 72. Okay, often with word problems, you want to actually answer the question. So if you show someone this, they'll be like, wait, what's the answer? So you want to answer the question. 1 pack of strings, Rosie, quiet, is $14. Now someone will be like, okay, I know what the answer is. Okay, that's the first one. Here's another problem. And this is a multi-step. There's more than one thing happening here. There's more than 2 things happening here. We have an M. M could stand for M&Ms. I don't know, we're gonna buy 11 packs of M&Ms, and then we got $8 from someone, so we don't have to spend that, and then we change our mind. We say, actually, I don't want those 6 packs of M&Ms, that's too much. So how do we deal with this? First of all, this is the given problem. It was in our book, or the teacher gave it to us. And the first thing we're going to do is, again, simplify. Simplify as much as you can before you start solving. So I'm going to put the 11m and this negative 6m next to each other. And I'm going to commute. I'm going to change the order of what I was given so that I can see the like terms next to each other. So in order to do that, you really have to see this as a negative 8, and you have to see this as a negative 6. Okay, you have to go back and forth from seeing this as a minus sign, minus 6m, to seeing it as plus negative 6m. Both of those are the same. Minus 6m and plus negative 6m are the same. So some people I ask, what is this? And they say negative 6m, this term. And some people say, oh, it's 6m. No, it's not 6m. You need to see it as negative 6m. This minus sign is stuck with the 6m. Okay, that's called commutative property. Commutative property. Change the order. You can do that if everything's addition, or if you're really careful with subtraction, you can move stuff around. Okay, 11 minus 6 is 5. So we have 11 m's take away 6 m's is 5 m's. That's combining like terms. We had 11 packs and we took 6 back. Now we're buying a total of 5 packs. And maybe someone gave you $8. All right, we're back to a 2-step. Okay, we're trying to find the value for m. And we have it multiplied by 5. And we have it, so the whole thing subtracted by 8. Okay, and we're going to undo those 2 steps. So remember, the first thing we're going to do is try to make a 0 pair. So I'm going to go into my head and I'm going to say, what do I put with this minus 8 or this negative 8? to make it 0. And what I have to put with it is positive 8. That came from my head. I decided that would be a good idea. If I do it to that side, I have to keep it balanced, have to keep it fair. So I'm going to do it to that side. This is called the addition property of equality. And where did the 8 come from? The 8 came from my head. Okay, now I have a 5m. This is 0. That's called the additive inverse property. And I'm going to call it the inverse property of addition. Okay, and I'm going to do 22 and 8, which is 30. I'm going to use the identity property because 5m and 0 is just 5m. All right, we're getting close here. What do we do next? We know 5 times some number is going to get us to 30. So the way to undo that is the division property of equality. Okay, make a 1 here. And we have an m, or a 1m, and we have a 6. That means each pack of M&Ms costs $6. Not a very good made-up word problem. Okay, that's the answer. So for this one, there was no word problem, so we can just box our answer here. We took something more complicated, we did some math, it got simpler, we did something on both sides, and then we had a 1 step, and then we had just the answer. All by itself. Sorry, this last step is the identity property. You could say simplify also. Identity property of multiplication, and you could say simplify because you simplified what 30 divided by 5 was, which is 6. Okay, if you're watching the video, pause it, try it. Okay, when you think you're done, you can start the video again and see if you got it right. I'm going to do this one without the justification. So pause the video now and try it. All right. Welcome back. We got negative 2y and 5y, and 5 is 14. I'm going to switch the order. I commuted the terms. Okay, a negative 2 and a 5y together make 3y. And now I'm back to a 2-step equation. I'm going to take off 5 on both sides because I know that's going to make a 0 pair right here. I have to keep it balanced, so I'm going to do it on that side too. 14, 12, 11, 10, 9, 8, wait, 14, 13, 12, 11, 10, 9. Okay. Whew. Almost did that wrong. Okay, 3y and 0 is 3y, identity property of addition. Divide both sides by? Good, the 3, not 3y, just 3. Okay, that makes our 1. We're making 1s and 0s. 1y is the same as 9 divided by 3, which is 3. 1 times the number is that number, identity property of multiplication. And did we get the value of the variable that makes the equation true? I don't know, we could check it. So this was our original. And we can put the 3 in where the y's are and see if we get 14 out. So I'm going to put a 3 there. I'm going to substitute a 3 there. And I'm going to see if both sides make 14. And this side is not going to change, right? It's just 14, 14, 14, 14, because remember the answers fall down the page. This is going to be a negative 1 plus a 15. Ooh, looks like I'm right. Negative 1 and 15 does make 14. So I got it right. Yay. It's a test, I don't have to worry. All right, that's the lesson for today. Oops, where's the algebra? Some students will look at multi-step equations and they'll say, teacher, you're doing too much. Like this is not right. But an algebra student knows that you can take it one step at a time and you turn the multi-step equation into something simpler. In math, we push through our challenges and persevere. Don't give up. All right, be good, do your homework. See you in class.